Hey, what's up guys? Welcome to a new video. This time we've got a WebAssign problem of fluid dynamics. In this case, you will see that the problem has two phases, which is question A and then question B. Now first we're gonna get the question A, but we need to read the question, right? The problem. So then it says that a cube of wood, here's my cube of wood, has an edge dimension of 20.3 centimeters. Now, it then has a density of 645 kilograms divided by cubic meters. Now it floats in water though, right? Now the question here says, what is the distance from the horizontal top surface of the cube to the water level? Now let's make a comprehension of the problem. So we've got that our cube has an edge dimension which is like a length of 20.3 centimeters, which we will write right here, which is now A, we're gonna call it is 20.3 centimeters, which this is 0, which is gonna be this is gonna be 0.203 meters. And now the density of the cube, we're going to write a P, which is P cube, would be 645 kilograms, blah, blah, blah. Now, the question is a little bit tricky. Maybe if you don't understand the question, don't worry. It says that the distance from the horizontal top surface. The horizontal top surface is just the top surface of the cube, right? Now, what is the distance of that thing, like right here, to the surface of water, to the water level? So we've got that our cube, we're gonna simplify things a lot with this drawing. So this is our cube, and we've got water in here. And so we're gonna find this distance is what we're gonna find. And this distance, we're gonna call it H. And then we're gonna calculate the submerged volume, then we're gonna operate with the volume of the total cube and such. So for that, we've got now that the volume of the cube would be to the third power, just a cube. So this is gonna be in meters. We're gonna work with meters, 0.203 meters cube, and plug in this operation in the calculator. We just get 0.203 cube, and so it would be approximately 0.0083 cubic meters. Now, the thing there's a formula here that we're gonna use that says, hey, I've got the density of the water. That says, hey, density of the water times the volume submerged of the cube, V sub, we're gonna name it, times the gravity. This is equal to the density then of the cube, which is made out of wood, right? So it's density wood times the volume of the total cube times G. Now, as you can see here, we can eliminate the G's. Whoops. We can eliminate the G's. So this goes here and this goes there. But we don't have the volume submerged of the cube, right? So what we're gonna have to do is that the volume submerged is just pretty simple. It's gonna be V sub would be equal to A. I'm gonna put a little arrow in here. So V sub would be equal to one side times H. Well, it's A squared times H. And so then we've got all our values in here. But we're gonna replace with V sub and V cube in here. which v cubed is a cube, as you can see now. So then this would be all equal to, I'm gonna put a little arrow in here. So that this is density of the water, which the density of the water is 1,000. I'm gonna write a little bit smaller though. And this is 1,000 kilogram cubic meter. So that times the V sub, which is a squared, times H. Now this is the density of the wood, which is right here, 645. 645 kilogram, blah blah. And then we've got here that then there's the volume of the cube involved. So we've got here that is just this unit. But I'm gonna write a cube. You'll see why then. So then this is times a cube. So now we only need to find the H for the moment, and we're gonna grab both of these guys to the other side. So this would be H would be equal to 645 kilogram times a cube. And we divide this by 1,000 kilogram cubic meter, and a squared. Now you can see now that these guys are gonna work with each other. They're gonna say, hey, I'm out of here and you're out of here. So then we've got A, you can obtain H. Now A is, remember, 0.203. So then this will be 0.203 meters. So now, and if we're gonna talk about a H, which is distance, it's gonna be meters. So just that. So this is one thing we're gonna do now, which it would be plug in our values into the calculator real quick. So we get a value. Oops. We get a value of 0.13 meters. But this is not our answer, our final answer. What we must do right now is, I'm gonna move this right here. We're gonna need to subtract H to A, because we just need this distance, right? So this little distance right here, well, this big distance right here is A. So then we need to subtract H to A to find the distance that we're looking for. So then it's A minus H, which would be 203, sorry, minus 0.13. And well, it's meters and meters, so it's going to be meters too. So then we've got that 0.203 minus 0.13 would give us a value, hold on, of 0.073 meters. Now this is the answer for the first question. And now we're going to be heading to the second question, which is question B, which will appear on screen in a couple of seconds. So question B says, what mass of lead should be placed so that the top of the cube will be leveled with the water surface? Now, what we're going to do here is we're going to calculate what mass should make the cube basically lower up to the water surface. What does it mean? So we see that the water surface is like maybe around the middle of the cube or such. Now we're gonna find something that we're gonna place on top of the cube. This is our cube simplified. and this will be called m, which would be the mass. Then that will sink the cube so that the water surface is just right on the same height of the top surface of the cube. So for that, we've got a formula that says, hey, I've got a B which is equal to Fg plus mg. So we see here that we're gonna get m, but what we're gonna do is we're gonna need to translate B and we're gonna translate F. So for that, B is just simply the density of the water times the volume of the cube times G. Now F, just F, is the density of the wood times the volume of the cube. So now what's next would be to replace this B and F that we just sort of translated. So then we've got the the density of the water times the volume of the cube times G is equal to the density of the wood times the volume of the cube times G, don't forget, times G plus mg. So then we're gonna need to clear m. So for that, we're gonna grab this big guy to the left side, but before that, boom, we could eliminate G. So then it is the density of the water times the volume of the cube minus the density of the wood times the volume of the cube. The volume of the cube would be equal to m. So we know that the volume of the cube is the cube of the edge dimension, the cube of one side. So this would be transforming to a cube, and then this is a cube as well. So now this is just the density of the wood, and this is the density of the water in here. This would be equal to m. So we can factorize both of these guys, a cube, the common term, but before that we're gonna move right here. We're gonna do what I said, which would be to factorize that guy. I'm gonna put m would be equal to the density of the water minus the density of the wood times a cube. So now what we need to do is just prepare our values, which would be density of the water, which is 1000 kilograms, blah blah, cubic meters, and we've got minus density of the wood, which is right here, 645, and 645 kilogram divided by cubic meter. Now for the a cube, it would be a value, remember, we're talking about meters, so I'm gonna have to move the decimal point, and for 2 spots to the left, so it's gonna be 0.203 meters cube. I hope you understand. So, but this is 0.203 meters cube. So I'm sorry, no, it's 0.203 cube right? So, but it's still gonna be meters. So then what I'm gonna have to do is I'm gonna plug my values into the calculator. So this gives us 2.97, 2.97, but it's gonna be kilograms. So this would be our answer, our final answer for question B, the second question. So this was a dynamics fluid problem of WebAssign with Bob, el profesor.